Hey folks, welcome to the November issue of the Flatcar Office Hours. In the office hours, we do a community outreach where we have folks from the community presenting. Sometimes we have demos ourselves, and so that'll happen today as well. I am seconding for Danielle, who usually conducts this meeting. She is at KubeCon, and she's probably still asleep by now. Flatcar is part of the CNCF, the CNCF project, and we adhere to the CNCF Code of Conduct, which is basically be nice to each other. Don't talk into each other's words. If you have the impression there's a person that just wouldn't stop talking, like me right now, please use the raise hand feature to get your voice heard. And by that, I open up the agenda. And the first agenda point is let's give new folks the opportunity to introduce themselves. I see Jan, Matt, and is it Mohammed? Mohammed, who are new to this call. Please feel free to introduce yourself. Let's start with Jan.
We have two Jans here.
That's true. We have two Jans.
Which one should start?
Yes, Jan Lavich from Jonas and Jan Brunitsky from the Flatcar team. Let's start with Jan Lavich.
So I should start. So I'm from Ionos. I have been working for Capgemini for 5 or 6 years as a DevOps engineer. Before that, I worked in Australia for half a year as a systems engineer. And have the background of like computer science, have been programming Go for a while. And what brings me here today is that we want to introduce Flatcar at Ionos, mainly to use it as the base image for our copy clusters. We are working with different hypervisors, KVM, Qemu, and Proxmox. So there's a couple of things going on. We have a pull request going on to support Proxmox, Flatcar images and image builder of copy, and obviously adding support for actual building Ionos cloud images at Flatcar. Internally, we already have the discussion going on to provide a test account to you guys so you could build actual images on our infrastructure or run tests. That's probably the most important thing here. That's all I have to add. I'm the core maintainer of OAuth2 proxy. If you have heard of it, it's a middleware for authentication, mainly used in Kubernetes. Have been doing that for like 2 years now. And the project is way older than my involvement. So that's about it.
Hi everyone. I hope my camera can actually function because I've been having some problems here with that. My name is Jan Brunitsky. I'm from Poland, from Wrocław. I am pretty new to the team. Oh, and all of my screens just reset. So is it working? Okay.
We can hear you.
Okay. Yeah. That's what I was saying. Okay, so I'm pretty new to the team. So for now, I was mainly familiarizing myself with Flatcar. I did refactor some of the tutorial stuff, and I'm looking forward to diving deeper into everything. And so far, I think that's all that I can say. So, yep.
All right, maybe Matt.
Yeah. Hi, I'm Matt. I'm in Asheville, North Carolina, in the States. I am bootstrapping a little startup that makes it easier for people to deploy and manage Docker. So I'm looking into Flatcar as a way to also not have to manage the host.
Great. We always love having new users here. Please absolutely feel free to make use of us and drop by the chats, and we're always trying to be very responsive. Great to have you here. Mohammed, do you want to introduce yourself?
Yes, sure.
Awesome.
My name is Mohammed. I'm platform engineer. I'm also from Ionos. My main focus is platform engineering. With provisioning of clusters with Cluster API. We do maintain 2 of copy providers, which is Proxmox and the Ionos Cloud. Recently we wanted to add support for Flatcar, and we thank you for all your, support and so on. That's it.
Awesome. I think Daniel still counts as new. You want to say a quick hello, Daniel? If you are saying a hello, then you're muted.
Still nothing, yeah.
Never mind.
Okay, I guess we can continue until.
Okay.
Yeah, there you are.
Yes.
That's a Linux audio.
Okay, sorry. I was just switching from laptop to dock. Yeah. So basically, I started at Microsoft 2 months ago, and I'm in the Flatcar team. So I'm working on Flatcar. Currently, I've been helping with the secure boot stuff with San and Shui. So yeah, that's about me.
Awesome. That's great. All right. Let's check the agenda. And we have 2 announcements, or just basically stuff that people should be aware of. The first one will disappear soon from the announcement section because it's pretty much done now, and that's the upgrade to Docker 26. And there were a few changes, deprecations from Docker 24 to Docker 26, most notably the storage providers. So some of the storage providers like Device Mapper just don't exist anymore in Docker 26. They have been deprecated since forever in Docker, but in Docker 26 they were finally removed. And since Docker 26 is now stable, it's also in the Flatcar stable. So we announced that, I think, for the last few months, so people know what's coming. And now here it is. This announcement will disappear. Krashimir, you have your hands up.
Yeah, I just wanted to point out that we have already Docker 27, I think, in alpha, but I'm not sure. Like, it got promoted to beta, so I don't know if it reached that stage yet. But yeah, we also had the Docker 27, and honestly, I haven't had a look like what has changed, what has been dropped between 26 and 27. So
not much. I actually did
possible that we need to update, the message that yet another thing got dropped from.
Yeah, no, actually, I did the difference between 26 and 27. Actually, also 26 and what is scheduled to be removed in 28. And it looks good. Like, it is as drastic as, oh, by the way, all your container images will be gone if you update to the new Docker. So I think very good. But from 24 to 26, there were a few scary removals that they did. But I mean, as you said, 26 is out, 27 is coming, and so we should be good with this announcement. And the other new thing that we have is we're gonna switch to systemd 256 or newer in the next alpha if we get it in time. So the December alpha is set to ship with systemd 256, and in that version onwards, C groups v1 support is entirely dead and removed. And it's not just unsupported, but upstream explicitly discourages the use and makes it really, really hard to actually still use it. So in Flatcar, we decided to not support C groups v1 anymore, because if upstream doesn't support it, we don't really have the resources to make sure that it's fully supported from our end. So that's gonna leave the distro. You're still safe until early 2025, when we expect systemd 256 to hit stable. And even then, you'll be able to use the LTS 2024, which will be publishing later this year. And that one will use the previous systemd version and will still have the cgroups v1 backwards compatibility. LTS 2024 will live for at least 12 months. So you're safe until the end of 2025. So you have a lot of wiggle room to migrate to cgroups v2. This will affect instances that update. So if you have an instance in v1 compatibility mode and it tries to update to a version that doesn't support that anymore, the update will be outright refused because we don't want to break your workloads. 1 second. And so you'll be able to mitigate the issue, to upgrade your instance to support cgroups v2, and then update to the newer version. That's the new scary message that we have, and it'll be part of all of our release communication from here onwards. Okay, all right. Now let's look at the agenda, and we now have Jan's introduction for Ionos. Jan, mic is open for you.
Let me share my screen quickly. So, is it starting for you guys? Again, share. Okay.
Yep, that works.
Okay. So, quick introduction to the company, nothing much. We are a German cloud provider, especially focused on like sovereignty and providing a cloud infrastructure mainly focused on governments.
Wenn zu Jans groben Not einfach ins Sekretariat gehen, fragen, aber ich schau mal.
Tilo, you are not muted. Okay.
I got muted.
Okay.
Okay. So I will continue. Yeah, basically we are a cloud provider based in Germany, and therefore interesting to like European governments especially. And what we want to focus on right now is like the support of Flatcar at the Ionos Cloud. We have a few special circumstances. We wanted to introduce a metadata server this year, but because of a large contract that is going on and that all departments work on, that was postponed. Therefore, we still are stuck with like a release, old workaround that directly injects data into the disks. Essentially, before VM starts, we have some struggle with ignition and cloud init support, which we can talk about in a sec. Basically, I opened this request for change or request for entry regarding all the changes we made. Everything is working. It was already tested by you, Thomas. Not Thomas, sorry. I always try to pronounce your username instead of...
Mathieu is fine, yeah.
Mathieu, exactly. And yeah, so basically, overall it's working. The main concern is currently ignition. And for that to work, we introduced the ignition patches directly into the script repository. And what I can show right now is how it already works in the Ionos Cloud. And then we can discuss how much we want to go into technical details. First, an overview. I activated dark mode so you don't get blinded. So we don't have a dark mode at the Ionos Cloud in our UI. So I just use dark reader. So don't worry about the weird colors. Basically, I created two VMs and I can zoom in a little bit, which one is using the cloud init support and the other one is the ignition patched support. And if we open the console, we can already see that this is working. So let's have a look. I just used the basic example of running an Nginx container, and yeah, it's still running, obviously. And the ignition results, what's the file name again?
Which one?
Where the ignition results are stored. Is it under run or var?
It's var run, yeah.
Var run ignition.
You have env and ignition. Yeah, .json is the payload you provided, basically.
Yeah, that's the payload exactly, and I don't have permission here. Yeah, so basically I provided a payload which I can show in a sec, better formatted properly. But yeah, this is using the ignition support, and if we close that right now, zoom out a little bit, and go into Cloud Init, this is the Cloud Init image. And that was configured using the Cloud Init file, so we can actually look at that. Cloud seed. Let's increase the size of this window, and now check user data. So, and again, this has been done using the Cloud Init config file. If we use less, we can actually see the whole file. So with this directive, ignition is ignoring it, and then Cloud Init is running because our infrastructure is still totally based on Cloud Init, and we don't have yet full ignition support for other images. We wanted to keep backwards compatibility for end users. So for us internally, we definitely want to use ignition as it's not more powerful, but for basic usage, Cloud Init would still work, and that was tested here as well. And we can check Docker, the image is up and running. And as you know from the other examples from the other providers, it's showing the host name on the front end. So for the Cloud Init network IP, this is now a public facing IP. Cloud Init is the host name. And where is it again? The IP of ignition is this one, also a public facing IP. And that now shows Flatcar ignition. So that has all been run through, and I basically just deployed it via Terraform, as for most other cloud providers, just read in the files, base64 encoded for our user data and the boot volumes, and then the machines start. And basically, yeah, I have one cloud config YAML file, which I encoded, and one prepared ignition file. And for those of you who are interested, it's like a basic example, just my public SSH key, some settings to don't allow root login, and then the basic Nginx unit, systemd unit. So that's about it regarding the running instances. So that fully works now. I'm quite happy with the current result. And now the question would be how to continue regarding testing, and how to continue regarding the ignition patches, because as of now in the scripts pull request, we have all the files for ignition in here directly. So if we scroll down, we can see the ignition files and added additional patches in here, or one additional patch with all the changes regarding Ionos Cloud support. And basically what I want to show to this round as well is the concern from the CoreOS people, which I totally understand. We currently, let's scroll down to the diagram. Yeah, so what we implemented is basically that for fetching the ignition config, we already mount the root partition, because with our injection scripts that prepare the VMs before boot, they inject the user data directly into the root partition. And therefore, we currently mount it before the actual initd mount from drug root or any init RAM as is happening. So basically, we mess a bit around with when root partitions are mounted, and it could happen that a device is not yet ready, and therefore they are concerned about this. Basically, because the actual ignition mounts and ignition file changes should only happen after the system root mount has happened, and we took that and pre-pended that. Basically, that's the issue right now. And yeah, I would like to give back the words to you guys if you have any questions or concerns, and how would you like to continue with the endeavor of adding ignition, Ionos Cloud support.
Yeah, thanks a lot for the demo. It was very cool to see it live. Before going into the ignition topic, I have a few questions regarding how you set up things. The first one, in your Terraform code, you deploy the instances. Can you upload the image directly on Ionos via Terraform, or do you need to upload it before by hand?
It has to be uploaded beforehand. I don't think Terraform can do that, to be honest. I will have to check that again, because usually that's something that is currently built anew, because another department is responsible for all things compute. So
Okay.
everything related to image and VM handling is another department, and they have a really long backlog. So currently the images are uploaded to an FTP server, and that is
Okay.
supposed to go away. So they should land in S3 buckets in the future, more dynamic, and then it would be easier to integrate it into Terraform. I don't know if uploading. No, I don't think it will work at the moment.
Okay. Okay, so you first need to get the image being available on the FTP server.
Yes.
Um,
So usually you can use basic FTP, or what I have done here in this for this example, we have our own Ionos control, and it has like an image upload command, and that is how you can upload images. I already have started writing the documentation for the website, so I can raise that pull request maybe tomorrow, and then you see the actual examples. Maybe I can even, let me check. Flatcar website. Why is this not? Yeah, okay. No, this is the old one, I guess. Where's my change? I will have to check. Maybe I haven't saved it properly or in another directory. But yeah, what we use is the Ionos control, and that can upload the files. And maybe, yeah, this is where upload. Yeah, that's how you do it. You just reference your file and then a location. So we have per region different servers where you upload your images, and then they are available in that region. And that has to be done manually, unfortunately.
Okay. Okay, thanks. And the second question is, by any chance, Ionos built on top of OpenStack? Because we got the case in a previous provider, which is Brightbox, and basically we can use all the underlying OpenStack components. But yeah, it's just by any chance?
No.
Okay. That would solve a lot of issues.
Yeah, I can imagine.
So for the ignition part, I don't have an answer. Fedora OS folks are not here in the call, I think. No. So basically, I see two ways of doing things. The first thing would be to wait before getting a user data service on Ionos, which seems to take ages. Because
unfortunately,
this is the case in all big companies. And the second one would be to maintain the downstream patch of Ignition, which means it won't be merged to Ignition, but it will be maintained by Flatcar in our patches of Ignition. So that's not ideal, but we already have a few downstream patches that can be upstreamed. Some stuff really specific to Flatcar. So that could be doable, but the thing I'm a bit worried is that Fedora OS and MicroOS from OpenSUSE won't benefit from this work that you've done. So that's a bit annoying because it means only Flatcar will be supported from the Ignition point of view on this.
Until we get a metadata server, because
until
then we want to have like full ignition and afterburner and everything, but that is currently just impossible.
Because from engineering point of view, it would be easy to maintain this patch downstream because it's something really specific to Ionos. It's only a file and that's it. So we won't get into any trouble when we will need to update Ignition into Flatcar. So that should be all right. But yeah, as I said, it's a bit boring for other users. My other question is that since you use Proxmox inside Ionos, or you have some interest into Proxmox, is there a way from Flatcar instances to mount a config drive or something like that when you deploy a VPS on Ionos, similar to Proxmox?
Yeah, you have to differentiate. So the customer VMs are not on Proxmox, just internal VMs we use for managing the overall cloud. So yeah, so basically there it might be used like that. Maybe Mohammed can say something. Yeah, Mohammed, go ahead.
Yes, I can say something about that. The way in Proxmox for now, we use the config drive and ISOs, but at Ionos Cloud, the problem is that we can't manage the ISOs. That's the real problem. Like the ISOs should also be uploaded to FTP servers and so on. So yeah, but I tested that, like if I include an ignition in an ISO file and then upload it and then boot it from there, it should work, but it's not convenient for the customers as well, for end users, because there will be a user data kind of field, but then how to kind of get this ignition.
So the issue would be that we couldn't, or the customers couldn't use the user data API attribute to make changes. They always would need to upload the ISO for the config drive manually beforehand, and for each and every VM, if you want to have something different in there, different SSH keys, you always would need to upload your new ISO manually. And so that would be way too inconvenient, I imagine.
Yes, Tilo?
Just out of curiosity, and I'm sorry for the noise earlier, I just picked the wrong microphone.
No worries.
Fix that. What customizations are we talking about? Like, what kind of customizations do you folks actually support when deploying instances on the Ionos Cloud?
What exactly do you mean by customizations?
The settings that you're trying to bypass through the ignition process, kind of what you showed at the beginning, and then make it apply in the instance. Are these user settings? Are these just Ionos Cloud metadata things that the instance needs to know?
So basically how it works, we have an injector script, I would call it, that runs before a VM is actually deployed, and it modifies the images provided by a customer and injects any user data the customer provides to the API. So when they request via actual API request or Terraform and inject user data, it could be cloud init config files, it could be ignition files now. This needs to be injected beforehand into the VM image, and then the VM starts for the first time. That's just how it was built like 12 years ago, and it was never changed and touched, and it is in use by hundreds, thousands of customers.
Yeah. So the user actually has the option to provide user data. It's just that in the backend. Okay. Thanks. That makes a lot of sense.
And the issue we have, the injection happens on the root partition, because how the script works, from my understanding, is it goes through all partitions of a drive or of the image that is provided and checks in which partition the etc directory exists.
Mm-hmm.
So it's quite brittle, to be honest, and it's a really dumb script. It just checks, is there an etc/cloud directory? If so, I will inject the data. Yeah.
So if you're looking for kind of like a stopgap solution until Ionos has a metadata service, then something that we might want to investigate is, so there are several places in the root file system where you can drop an ignition snippet, and that snippet will be acted upon. I think the most blunt way would be in the OEM partition with a Ionos SysEx, Ionos OEM SysEx. That's basically generated on the fly by the provisioning logic, kind of the same way that it's currently modifying whole disk images. But in this case, it just generates a sysx with a single ignition file in it. Right? Does it even need to be a sysx? Maybe it can just be a plain ignition file. It drops it in a well-known path in the OEM partition, and then ignition will automatically pick it up when it boots. So that would be a nice way to kind of side channel any user-supplied ignition. Matthew, correct me if I'm wrong.
Yeah, I get the point of chaining things. Like you have a base ignition configuration in the OEM, but then what? How do you provide the user data from the user point of view?
No. I don't think we need a base ignition file in the OEM. That can be the user ignition file.
Yeah, but how do you inject the ignition file into the OEM?
That's exactly my point, because
still by modifying the image, but it would be way more robust, right? So you would just add into the OEM partition a Ionos OEM sysx that has this ignition file. And it's just a workaround. I'm not proposing that as a viable path forward, but it would basically allow us to bypass the whole modifying upstream ignition and carrying patches on top of our ignition topic, and use mechanisms we already provide to support Ionos.
Yeah, but I'm not that experienced with. Sorry, not here.
Yeah, I was just answering to Thilo. It's Ionos that inject the user data into /etc, Thilo. So it's the cloud provider that modified the image itself. So it's
that's my point. And just instead of putting it into etc, we could put it into the OEM partition as the Ionos OEM sysx, and by that.
Yeah, but for that, the injection script at Ionos would need to change, and that team is not willing to do anything on that script because they want to. Yeah, that's the whole issue, because that department has a really long backlog, all things compute, metadata server, other things, new servers for uploading. They have a really long backlog, and they are not willing to touch this old script because it's running, and they want to introduce new stuff, and until then, they are not willing to make changes. That's the whole issue we have.
Yeah, no, that makes sense. That makes sense.
And you mentioned that we can upload the images on FTP. So what if we would inject the user data on FTP, and Ignition will fetch the user data from the FTP server? Because this is something Ignition already knows how to do by default, to fetch FTP stuff. So I'm just brainstorming, trying to find.
So that FTP server doesn't allow for uploading other files than images. So it's really restricted in terms of which file endings and extensions and types you can use. So there is an API that checks, and it will not process any other data. Okay. We do have S3 buckets, and you asked me that before, if that would be a possibility. But even then, that would work. On the other hand, we already have the user data API attribute, and then that would be useless because it wouldn't be used until we have a metadata server. So my whole concern was keep it as simple to the users as possible. Don't introduce like workarounds for users to have to create a bucket, then upload stuff in there, and before they can even start a server. So then you have this whole dependency on S3 buckets, which I didn't want to introduce.
Yeah, makes sense.
It also feels like we're trying to design a metadata service. So I get it.
Yeah.
Let's not overthink stuff. That makes sense.
Yeah, and basically to show you my implementation of the Ignition quickly. So what we do, we check for the root label. We can even change it. And then basically, where is it happening? Device label. Fetch config from device. Am I blind? Make dear. Move, compare, here, mount. So that's it. So basically, we are mounting a device, and in this case, the device is just the partition that has the root label. And that is how we have done it, and it works for Flatcar. I totally get the concern of the Ignition guys that this is not the intended way, because the root partition shouldn't be mounted before the actual init RAM of S is doing it. But yeah, for us right now it works.
And I mean, we allow customizations of the root partition, and we actually in some cases have scripts that do it.
Yeah,
So I can't really complain about that path forward. If you wanna, so I dropped a link in the comments. If you wanna check that part of the documentation, it'll have a few well-known paths where you could actually put Ignition files and it would be picked up. And some of those are outside of the root partition in separate partitions, which may or may not might make the whole thing more robust. And since you're dabbling with that already, I think it's a good additional item, at least to know about.
Yeah. I will check if we can build some kind of workaround, or
But yeah, I think we still need to think about it and try to find some alternatives. But yeah, the final decision would be to maintain downstream patches. But yeah, if we can avoid to do this, like so everyone can benefit from this work, that would be awesome. But
yeah. I mean, the vacation period around Christmas and stuff is coming up, so I won't get much information, but I try to get a hand on the compute department again and see if they have a timeline for the next year when the metadata server might be introduced. If it will be introduced, let's see. And yeah, maybe we can persuade them in that it identifies if the distribution is Flatcar to inject the data somewhere else. I mean, that isn't a huge change. Yeah, I will have a chat with them once more, because that would make a lot of stuff easier for us.
And for everyone, because instance metadata service is really standard across the cloud providers. Almost, I mean, every cloud provider has this kind of service. So I think that would be a great decision for IONOS to invest on this.
I mean, it is planned. It was the initial draft and was done like 1.5 years or 2 years ago. Or, so yeah, it's just because of huge contracts with governments and stuff that got a higher priority.
Yeah. But yeah, okay. And final thought on this is that you can join the Fedora CoreOS Matrix channel and you can ping folks on it, and we can try to have a brainstorming session, all of us, to try to think a solution, or at least to discuss about this with them.
Yeah.
But yeah, thanks a lot for your great work. That's really great to see that. From the Flatcar point of view, it's really cool to have everything implemented.
Absolutely, yes. Let's keep the discussion going. Like let's not discourage ourselves just because we have multiple options and workarounds to pick from. And actually, the festive days are a very good opportunity to lean back and meditate over, and maybe we can come up with something that works as a bridge until the metadata service is there. So I really like the introduction. Thank you for taking the time.
All right, you're welcome. Thanks for all your support and the good documentation. It was sometimes frustrating, not because of Flatcar, just getting used to like the Gentoo basis of stuff and emerge and so on, because I'm not used to it. I haven't used it before. But overall, what you guys built for Flatcar and the documentation is stellar. So thanks for that.
Awesome. That's great to hear. Keep the conversation going. Just check back with us and make sure that we stay on track. That's great work.
Yep. Great.
All right. Let's get to the second item on the agenda today, and that's a brief intro to the SysX Bakery. I'll make it really brief to not keep you longer than necessary. Let me share my Linux screen. Here we go. And go through the presentation. All right, this is a brief walkthrough to the Flatcar SysX Bakery. And we'll start with a general idea of what SysEx are, just to repeat the foundations here. So a SysEx, or system extension, is a full file system image that contains a whole file system, and it will only ship the binaries in that file system of the features it needs to actually ship and implement. In the example on the slide, we're looking at a Kubernetes SysEx, so it ships the Kubernetes binaries. This file system image will be merged by a tool called systemd-sysex into the rootfs image, and it'll make it appear as if both the sysex binaries and the rootfs binaries are part of the rootfs. You can merge and unmerge a whole stack of sysex and make the respective binaries and libraries appear and disappear in the root file system. It's been around for some time. It's introduced 3 years ago in systemd version 2.4.8, and version 2.5.6, which was published in May this year, added mutability. Previously, you couldn't write to /usr if you had a sysex merged in /usr. That changed now. You can do that now. How do we use sysex in Flatcar? There are 2 basic categories of sysex. The first are operating system dependent extensions, and the others are independent extensions. Operating system dependent extensions depend on some libraries of the base operating system image. And we actually ship some of those extensions inside of the base operating system image. Good examples here are Docker, Containerd, or the OEM tools sysex that is different for every vendor, and that usually contains, for instance, guest tools for virtualized environments like AWS or Azure, or specific tools for hardware environments where the image is being built for. This is in the base operating system image, is updated as part of the base operating system image. And then we have optional extensions. Optional extensions are not shipped with the base image. You can enable them by just piping their name, by writing their name into EDC Flatcar enabled sysexconf. That can be done at provisioning time using Ignition. And those are also system dependent because they depend, say, on the C library or the crypto library in the base image. Good examples here are ZFS. We have a ZFS sysex, Python, or Podman, which we all support as optional images. Now, these are version locked. So sysex metadata comes with a version string, version ID, and that needs to match the running operating system, or sysex won't even merge the respective extension. And all of these are basically in lockstep with the operating system, and they are updated by the operating system update tool, which is Update Engine. So that takes care of both the base operating system and all of the active sysex. And then there are operating system independent sysex. Those have binaries that don't have any dependencies on the base OS other than a running kernel. So no library dependencies, statically compiled. Good examples are Kubernetes, one of the large language model runtimes that we support, Tailscale, and a bunch of other things. And one way of getting those are from the sysex bakery, which we're going to look at in this talk. And the other one, you can entirely host and build and host those yourself. These have no version ID set, using the magic string _any, and they are updated independently. In fact, they ship with their own update mechanism. That's very easy to use and very, very easy to host updates for. Now let's look at the bakery. So the Flatcar sysex bakery serves 2 fundamental purposes. The first is it contains a number of scripts to actually build those sysex. And these scripts would basically download the release binaries from the official release pages, put them into a subdirectory, and then from that subdirectory build the file system image. And you find the examples I've used in a previous slide in here as well. So you have a create Kubernetes script, create Ollama script, and create Tailscale script. You also have a script called bake Flatcar image, and bake Flatcar image uses the Flatcar SDK to bake any local or remote from the bakery sysex into a Flatcar image, and then creates a Flatcar image for the vendor that you choose. Bake Flatcar image supports all of the Flatcar vendors, and you can basically prepare a full disk image for provisioning using that script and then put it somewhere and then provision it there. The other fundamental purpose the SysEx bakery serves is it actually provides ready-made, ready-built SysEx for you to consume. And we use the GitHub releases feature for that. So there's only one release, and that is the latest. And that's because it gives us predictable URL. And from that URL, you can download SysEx on a variety of versions. And you can also use that URL to provide it to systemd sysupdate, so it can go and check for updates there. Again, here are the examples I used previously. So we have a number of Kubernetes SysEx there, or Llama SysEx and Tailsky SysEx for you to consume. Which brings me to how do you even consume those? Well, it basically, so the easiest method, if you don't want to use Bake SysEx, Bake Flatcar image, is to instruct your provisioning logic to download and to store on the root file system any given SysEx at provisioning time. And from there on, you'll be able to use it. It'll automatically be merged into your system. The by way easiest method to do that is to instruct Ignition to please go to the SysEx bakery releases URL, get the SysEx you want, and put it straight into etc extensions where your systemd SysEx can see it. There is a slightly more advanced method that we're using most of the time, but you see here that the predictable URL GitHub gives us with the latest release version leads to that URL being predictable in the provisioning configuration, so we can use it for provisioning. What we usually would do is we would actually download it into a custom storage directory. So that directory, opt extensions Kubernetes, is not something systemd SysEx is aware of. You can just put the image there and put other images there as well. And then we create a symlink from that actual image to the image, to the path where systemd SysEx checks for available SysEx to be merged. We do that because that allows us to update SysEx. So let's talk about updating SysEx. Updating SysEx uses systemd sysupdate, which goes and checks an HTTPS endpoint and an index file that is stored on that endpoint for newer versions of SysEx under systemd sysupdate's control. If a newer version is found, it downloads the newer version, it stores it, and then it updates the symlink that we've just seen to point to the newer version. And then you would either need to refresh your local nodes to make the update apply, or to reboot your local node to make the update apply. All right, here's our provisioning configuration from earlier. We now just add one additional file, and that is the configuration for the sysupdate service. And in that conf file, we'll point sysupdate to the releases for the bakery SysEx, and then we'll download those. So as you see here, the releases, the conf file is actually also part of the releases, so you can consume it right from the same URL. And in this example, we're actually only updating patch level releases of Kubernetes. So let's take a look into the sysupdate conf. For systemd sysupdate, the name of the application or the name of the SysEx is Kubernetes-v130. Sysupdate is not aware that v130 is a version string. Instead, it will only look after for version information after the dot after the 30. And if a newer version was published on the HTTPS endpoint that we provide in path, then it'll download it. You can be adventurous, by the way. So we do that. That's probably a good idea to tell you that we do that because upstream Kubernetes does not support like streamlined, in-place, seamless upgrades from one Kubernetes major release to another. So you shouldn't, without configuration or testing, update in place from v130 to v131. they usually require manual intervention, and that's why we basically do only the patch level upgrades in our automation here as well. But if you feel adventurous, you could totally give system sysupdate control over the full version string. So this semantic version aware, it'll able to pass the version string, and it'll be able to understand that v1.31.0 is higher than v1.35, and it'll stage it and provide the update for that. And that's basically it. That's all I had for my intro. So the bakery provides operating system independent extensions. Theoretically, those could be used on any distro, not just Flatcar. They can definitely be used across all Flatcar releases that support SysX because there are no dependencies on the underlying operating system. They include optional automated updates. They're actually also very easy to self-host. Like you can totally create your own GitHub releases for your own SysX or host them entirely elsewhere because all you need to host them is an HTTPS endpoint. The bakery allows you to customize and extend the base image, adding Kubernetes, Tailscale. There are two WASM runtimes there. There's the Olama large language model and other stuff. We are very relaxed actually with accepting PRs to the bakery. It's kind of a contrib thing for Flatcar. So if you want to have your own SysX there and have us refresh those builds regularly and provide the SysX for consumption on the bakery, just go ahead and file a PR. We are very happy to have you. It'll also allow you to pilot and test drive latest and greatest stuff that we haven't integrated in Flatcar yet. Most notably right now, that's the Containerd 2.0, which offers user namespaces and a lot of other new features. We haven't fully integrated it in the base image yet, but you could mask the Containerd that is shipped with the base image and go with the Containerd from the bakery, or test drive entirely new Docker versions, which we haven't added to the base image yet. So that's also stuff that you can do with the bakery. And that concludes my little presentation. I'm going to stop sharing and give the word back to the folks. Any questions? Shui.
In your config where you configured the updater, you had the static version as well. Do you have to give like an initial version for it to start with, or can you just point it at the updater and it will get, you know, the latest one for you?
You could just point it to the URL. Actually, that's a good question. So technically, if you configure sysupdate, you don't necessarily even need to provision an initial sysx, because sysupdate will notice that there is no sysx at all, and you just use the latest version that's available. It just makes the provisioning less predictive, because what Ignition does is when you specify Ignition any file for download and that file isn't there, then Ignition would just stop in the RAM disk and only continue after it got that file. While if you do the entire thing via sysupdate, then your instance would boot and there's just parts of the instance would be missing because the sysx isn't there yet. But technically, that would work.
Okay, thanks.
Cool. All right. Then I don't know, Cyan, are you ready? I read in the chat that there's issues with the internet connection.
He said,
You are saying
join
something,
from
you are
his
muted.
phone.
Can you hear me?
Yeah.
Okay, so I joined in via phone, and I can give an update on how the release planning is. Is that okay?
Awesome. Go ahead.
Cool. Yeah, sure. So in the so there's not much update in the backlog or the work that we have been doing. The team has been primarily working on getting like the work that Matthew is working on the Proxmox support and others. We also have a few the package weekly package updates that Casimir has been working on, and the secure boot work that me and Chui and Daniel have been working on. So there's not much update on that side, but on the release side, we are in between a release right now, and this includes a major alpha, beta, and stable release, and the stable is. As mentioned, would include a Docker update, and as Thilo mentioned, that this is also the base for the alpha having the, like, we would be deprecating. So we in the next few hours you will see the Docker deprecation message being gone and the C groups message being up. So yeah, we are in between a release for the major stable. So please test your environments. If you feel if you have any issues, feel free to raise those issues on Matrix or file an issue on our ticket tracker. And I guess that's mostly from the release side. Casimir, Chui, Matthew, or Daniel, Jan, do you have anything else to add?
Nothing from me.
Nope.
No, except that the release is done.
Oh,
During the
great.
office hours. So you can update. Well, you have nothing to do. You can just wait to get the update.
Sure, great. So I think that's all from release side. Over to Thilo.
Nice. Thanks for the update. I'm also very happy that the release went well and we have a new major stable and all of that. This stable release is kind of on the path of becoming the LTS 2024, right?
Correct. Yes.
Awesome. All right. So people might want to have a look. Great news, folks, and great work. All right. Yeah. So that brings us to the end of the meeting. If there's anything else you want to talk about, please bubble it up right now.
I just realized what your background is.
But yeah, right. Recognize it. Awesome.
Usually it was some deep space, but yeah.
Yeah, not today. Today I'm in the pub. Beer garden.
Thanks again for all your input and help. So talk to you soon.
Thanks for dropping by. It's amazing. It's always awesome to have new folks here and see what they're doing with Flatcar. I'm actually very curious on what Matt's going to do with Flatcar in the future. That sounded exciting as well. So thanks for joining, everybody. Enjoy and have a great time, and see you on Matrix.
See you. Bye-bye.
Bye.
Bye-bye.